Okay, we have to propose the mechanism for this reaction. So this is slightly tricky. You just copy and the medium is acidic, so you have to write mechanism in the presence of H plus and that is the acidic medium. So now I know one thing, that is the medium is acidic. So you have to write mechanism in acidic medium. Now you just copy and think what can you do. You see this sulfur first is attached to this carbon. It's this carbon, that is a benzene ring and this ring, and now this is attached, of course this is attached to now see this carbon. It looks like, let us check, you have this oxygen, and now there is only one oxygen. So one thing is clear, there is a loss of one H2O molecule. So I know one thing, there is loss of H2O. So loss of H2O is there. So one thing is sure, there has been one molecule of H2O has been lost. Now I have two options. I can lose H2O from here or I can lose H2O from here. If I lose H2O from here, I will have basically a plus charge, either is resonance stabilized by sulfur, or that is called neighboring group participation. Are you getting or not? So you can have something called neighboring group participation. It looks like, so this is a problem something related to NGP, neighboring group participation. So it looks like there are something like neighboring group participation. Now you see, if I make a carbocation here and if I try to attack this oxygen, what is the size of ring? 1, 2, 3, 4, only 5 membered ring I will have. But now you also see this oxygen, if I take this oxygen as a nucleophile, so one of the OH is acting as a nucleophile, you can say primary alcohol is acting as a nucleophile. So let us say I have another hint, that is primary OH acting as a nucleophile. So this is basically acting as a nucleophile. So this is acting as a nucleophile. So this is another hint I have. So this may be acting as a nucleophile. So now if I use all these ideas, now if this attacks, oxygen attacks here, I will have only 5 membered ring. But if this oxygen attacks on this carbon, I will have a 6 membered ring. And this oxygen is also connected to this ring, and that is my task. So you think, how can you do this one? So let us say you have this compound, first you have benzene ring here. So let me write. So this is the benzene ring. So you have benzene ring. And then here you have a sulfur. And then you have a, here you have a 6 membered ring, cyclohexane. So you have a 6 membered ring. And then here you have OH. And then you have OH. Now what you can do is, first step H plus attack, loss of H2O. So I have H plus, this H plus goes here, and in the same step I am losing H2O. So there is no need to make the same thing 2 times. So I am losing H2O. So if I lose H2O, what I will have? I have a benzene ring. So this ring is there. And then I have a sulfur here. Sulfur contains lone pair. And then this sulfur is basically connected to a 6 membered ring. So I have a 6 membered ring here, cyclohexane, and now I have a carbocation here, and then I have this. So this is the final. Now you see, I can have this sulfur basically having 2 lone pair. Now this can basically, this lone pair can attack on this carbocation to make this carbocation stable. So this attacks here. So what you will have, if you have something like this is called neighboring group participation. So this is NGP. So if you have something like this, you will have a cyclohexane ring, and then you have here sulfur. So this sulfur, and then this side you have a pH group, that is a benzene ring. So let us write pH, and this sulfur is basically connected to, so there is a 3 membered ring. So this carbon is connected to sulfur, carbon connected to cyclohexane, and then you have this same thing you have to copy, OH. Now you see another advantage I have. So this ring is a cyclopropane ring, is a ring strained. So this is a strained ring you have. Are you getting or not? So this is a strained ring here you have. Now this ring can be easily opened. And you see, if you see the product, you have to have one oxygen attached to this carbon. So basically what can you do? You can do one thing. You attack this oxygen on this carbon, open this sulfur. Are you getting or not? So what I want to say, so let us say attack this oxygen on this carbon, and then open this carbon this side, open this bond this side. So if you follow this step, so what you will have? So if you follow this step, you will have a cyclohexane ring. So there is a cyclohexane ring, and then you will have this lone pair. So this oxygen is connected to this carbon. Are you getting or not? So what you will have? You will have 1, 2, 3, 4, 5, and containing oxygen 6-membered ring. So you will have here a 6-membered ring. So let us make a 6-membered ring. And this side you will have a oxygen. Are you getting or not? So this side you will have a oxygen, and you will have a 6-membered ring. So this is the 6-membered ring you have. Are you getting? So this is the 6-membered ring you have. And then you see on this carbon, so this carbon, that is carbon on the ring, and then next carbon have sulfur and pH. So next carbon contains, so this carbon contains sulfur and pH. Are you getting? Obvious. In this case, basically this sulfur has a positive formal charge, so that I can also show. And now there is no formal charge on sulfur. Basically now oxygen will have a hydrogen, and that will have a formal charge. So what you can do in the next step, you lose H plus. So if you lose H plus in the next step, the final you can write. So you have a cyclohexane ring here, and then you have a 6-membered ring. So there you have a 6-membered ring, and here you have oxygen, and then you have a 6-membered ring. So let me write. So there is a 6-membered ring, and then I have here sulfur and pH. Are you getting or not? So this is easy one. So one important point in this problem you have, that is something called neighboring group participation. This oxygen has 2 lone pairs, so I have to show these 2 lone pair also. So you can check the product. So finally you have the same thing. You have here a benzene ring as pH, that is I am showing simply this is a pH. If you want, you can show say exaggerated way, there is benzene ring.